Next report, before Alexander Markovich Fainleib, a new polymer nanostructured binder for high-performance carbon plastics for aerospace application. Nanotechnology of producing hybrid organic composite materials of high thermal stability, adhesion strength, and low dielectric loss.
So I can do my presentation in English or in Russian. Yeah. Okay.
Please in English.
So this work was done in the frame of the project and this nanotechnology and nanomaterials program, and we developed the novel solvent-free polymer nanostructured binder for high-performance carbon plastics for aerospace applications. So what was done? We made several developments, and all of them, most of them were done on the base of very promising thermosetting material is cyanate ester resins and different dispersed inorganic nanoparticles. As nanofillers, we used multi-volt carbon nanotubes, epoxy functionalized polyhedral oligomeric silicious spores with nanoparticle size 1-3 nanometers, and also functionalized montmorillonite. And what are cyanate esters, and what are the advantages of cyanate esters? They are thermosetting resins which can be processed very easy with a similar technology as epoxy resins. And they give at high temperature curing the densely cross-linked polymer networks, thermostable network with high glass transition temperature up to 400 degrees centigrade, loss dielectric loss, high adhesion to different substrates, and also very low water uptake. So you can see today's best known applications in aerospace industry and Formula One racing cars. And on this slide you can see the chemical structure of some commercial cyanide ester resins produced by CTEC Aerospace Materials, Henkel, Hexail, Huntsman Advanced Materials, and others well-known companies for producing binders for composite materials. And end users, Boeing, Airbus, NASA, British Aerospace, Navy, and others. So we used as a prototype, for comparison, we used the conventional epoxy binder, industrial epoxy binder ADT69N, and some analogs ADT69, ADT10 for carbon plastics, developed by Viam, Moscow, Russia, many years ago, and it is still widely used in Russia and in Ukraine as well. This is a mixture of several epoxy resins and the curing agent from amine class, and the mixture of the solvents. And what is the problem of this binder? It's necessity of using solvents which are toxic and lead to environmental pollution, and low thermal stability, low strength and low adhesion to carbon fiber at temperature higher than 80 degrees centigrade, and also high porosity of carbon plastics, more than 20%. And it cannot give us the safety of the final product. Aircrafts, for example. And what is new in our binder? We use the same mixture of epoxides, and we replaced the curing agent, amine curing agent, by cyanide ester resins, which is a multifunctional agent in this mixture. It plays the role of solvent because it's low viscosity component. Then it is a curing agent for epoxy resins because it reacts very easy and actively with epoxides. And also it creates its own densely cross-linked polymer networks with heterocyclic fragments in the network structure. And also we use the nanofiller like this. It's was the technology and different methods of preparing the binder was patented in Ukraine. And what are the advantages of this material? No using toxic organic solvents, zero porosity of carbon plastics, high mechanical performance up to 200 degrees at long time service and up to 300 degrees short time service, as well as at high humidity. And we can play with the composition to correct the properties. Lower binder content in carbon plastics, which gives lighter aerospace constructions by 8–10%, and significant improvement effect without changes in technology, because manufacturers would like to get some new and better without any serious changes in technology. This is important. So here we can see the properties comparison for polymer matrix and for carbon plastics of new and old binder. So for elastic modulus, you have extraordinary increase in properties in elastic modulus value by 25 times at 200 degrees centigrade. Also, glass transition temperature increased by 84 degrees centigrade. That is a very important and significant value. Also, at 150 degrees, tensile strength and flexural strength of the carbon plastics obtained, we have a serious improvement in the value. And why we have got these results? We try to explain this from a chemical point of view, the chemical formulas. So we fixed formation of several heterocyclic structures, and due to reaction of cyanide groups with epoxy groups, we have the hybrid network structure with organic, like this, cyanurate cycles, and inorganic particles individually incorporated chemically into the network structure due to chemical interactions. So we suppose that each 1 nanometer size particle is separately incorporated to the polymer structure. And it is confirmed by TEM and Sachs, which show the perfect distribution of the nanoparticles inside the polymer matrix. And here we have 50–60 degrees centigrade improvement in thermal degradation stability of the new material. And we tested our binder in Antonov Aircraft Company and Design Bureau Pivdena in Dnipropetrovsk, and we got very good results. We have some documentational confirmation as for testing and for using. And what are the plans and perspectives? So we plan to produce the pilot bench of the product around 2 tons in 2015 for using these companies. And I would like to say that it seems to be more easy to commercialize the product at space industries and in aircraft industry, because even after 23 years of independence, the new materials which we would like to commercialize at the aircraft have to pass certification in Russia, in VM Institute in Moscow. It's incredible. So we would like to initiate creation of national certification center for novel materials used in aircraft industry. For example, on the base of the institutes of macromolecular chemistry for problems of strength and problems in material science and maybe others. It's very important for new materials. Then we also would like to optimize the binder composition and technology of carbon plastics producing and curing schedule to estimate where are the temperature limits of these new materials. And to adapt, and we also would like to do adaptation of this binder to other technologies for glass plastics as adhesives and coatings and encapsulates in microelectronics. So who work on cyanated ster resins in Ukraine? It's our group. We have some achievements during last years, 2 decades. We published the book in the United States, and 18 chapters in books, 86 papers, 8 multi and bilateral European international projects, 16 international grants, 22 patents, many presentations, and 7 PhD dissertations. Thank you for your attention. This is a team.
Thank. Very impressive advantages as for me. Please, questions to the author?
Скажите, вы говорили, что применение в основном для самолетостроения, для космоса там температурное, а с радиационной точки зрения стойкости что-нибудь видно по вашему?
Other questions, please? No more, but I agree with authors that it is very important to organize the certification in this direction in Ukraine. I am surprised that up to now we must certificate in Russian for aerospace. Yes.
Thank you.
Many thanks.